Hey everyone, in this video we're going to go through some harder financial maths problems. So as we move through these, I will be referring to your summary pages. So just make sure whenever you do any questions that you're actually referring to them and getting used to using them and familiar with what information is on each of those summary pages, because the more you use them, the easier it's going to be to answer questions. And you might not even need them, but they're there, and it's better if you're not trying to search for the information, you're already familiar with using it. All right, so Wanda invested $20,000 at 7.1% per annum, compounding annually. She makes regular deposit of $6,000 per year into the account. All right, so let's highlight the important things. So it is an investment, which is important. $20,000 she's investing. The annual interest rate is 7.1%. She's depositing $6,000 per year into the account, and it's compounding annually. I just missed that. So usually your compounding periods and your payment or your deposit periods are the same. So that's why when I saw that was year, I was like, where is the compounding periods? There it is, annually. All right, so first of all, I'm going to answer A and B together. So question A is PV positive or negative? And is PMT positive or negative? So what it's actually referring to is the financial solver. So if I just get your financial solver up so you know what I'm talking about. All right, and this is going to be compound interest. Most of these more complicated questions are compound interest examples. So your PMT and your PV. So you can just press, if you need to know what it means, you can just go to help down the bottom. All right, and then I'm going to, go here. Present value, also known as the principal value, and then PMT, the payment made each period. All right, so that's your PMT and your PV. All right, so you might already know what it is, but if not, let's go to the summary page. I've got them all up the top here, so it might just take me a bit of getting used to. Which one was it? Investments and loans, the black one. So because I'm used to these, I've used them quite a bit now in these videos, I already know what they look like. So I thought, oh, this is the black page. And what I mean by that is we've got a black border. So I can already think, oh, I know what summary page I've got to look at. All right, so it's an investment. So your PV is negative and your PMT is also negative. So your answers are already there. The reason they're negative is because the money is going to your bank. All right, so remember, once it goes out of your pocket, well, technically it's probably coming out of a different bank account, but let's pretend you've got that cash in your pocket and it's going to the bank as an investment. It doesn't mean you're losing money, you're just investing it in the bank. So goes out of your pocket to the bank, it's negative. It's funny, when I actually say this, I'm using my hands and to gesture, moving from the pocket to the bank, but you can't see my hands, so there's no point in doing that. Anyway, so both of them have to be negative because both of them are payments made to the bank. Find the value of the investment after 10 years, round your answer to the nearest cent. And then part D, I just want to read as well to see if it's, so find the value after 30 years. All right, so we're pretty much doing the same thing twice. So on your financial solver, first of all, and again, we've got the help down the bottom if you need it. So N is the number of installment periods. So we've got 10 years, and because it's compounding yearly, it's just going to be 10. So if it was different, something other than annually, we'd need to think a bit more about our value of N. Now, I is always your annual interest rate. So in this case, it's 7.1. PV, your principal value. So remember, it's going to be negative because it's going to the bank. And your PMT is also negative. Oops. Come on, move down. Because it's also going to the bank. So 6,000. Now, don't forget your, down the bottom, we've got our installment periods. So it's still 1 because we're doing it annually, and your compounding periods is also 1. All right, so if it was monthly, they would be 12. All right, we'll probably come across some questions there. All right, so we want to calculate the future value, so we just press on that. You can press solve down here, same thing. All right, you can copy that answer down. So 123,000, and $3.55. So just make sure you're doing it to 2 decimal places and you're rounding correctly. All right, so for part D, the only thing that changes is value of N is now 30, so it's 30 years. And we want to just change the future value. You don't need to delete it, you can just press on it again. So you get $733,636.83. So not bad if you invested $20,000 and then for 30 years time, but you are adding $6,000 a year. So that's why it's increased so dramatically, because you are actually adding extra repayments, not repayments, sorry, extra payments to your investment. All right, let's have a look at the next question. So Barry borrows $8,000 at an interest rate of 4.5% per annum. I'm just going to highlight as we go along. All right, so he's borrowing. So it's a loan, $8,000, interest rate of 4.5% per annum, and this time we're compounding monthly. Also says here the loan, so make sure you know whether it's a loan or an investment. It could also be an annuity or a perpetuity. Annuities are somewhat okay, but perpetuities sometimes students get a little bit confused. Not too complicated, and I did do a video explaining the difference between the two. This loan will be repaid with regular payments of $350 per month, followed by a final payment. Okay, so if we're repaying a loan, because it's compound interest, usually the amounts aren't all equal. All right, so you might be repaying, for example, $350 per month, but it's usually never going, your final payment is never usually going to be $350 exactly. All right, so let's answer the question first. So we've got PV and PMT, positive or negative. So again, let's have a look at getting used to using our notes. Right, we're doing a loan. It doesn't say reducing balance loan, but if you're using compound interest, it is a reducing balance loan. So your principal value or your present value is positive and your payments are negative. The reason for that is because you're getting the money from the bank, so it's going into your pocket, so it's positive, but then you're making repayments back to the bank, so that money's going back, so it's negative. All right, let's just get my pen back up. All right, so we're going to have positive, oops, I thought I changed you. So it's going to be positive, and then the second one's going to be negative. How much does Barry owe after 6 months? Round your answer to the nearest cent. So again, on the calculator. Okay, so he's only had it in for 6 months, so it's just going to be 6 there. Changing our interest rate to 4.5. You notice I'm just going over what I did before. You could clear it if you wanted to. Probably a better idea to clear it, but we're already there. So, all right, so CPV is positive, but our payments are negative. Future value is what we're calculating. Now this time PY and CY changes to 12 because our compounding periods and our payments are made monthly. All right, and then our future value. All right, so $6,061.91. So just making sure you do that correctly. Now, I know it doesn't ask in this question here, but if you had a question that said, well, how long would it take to repay this loan? And we're probably going to have a question like this in a sec. So that means your future value is going to be 0. These are supposed to be harder questions. I don't find them harder at all. Maybe the next ones are going to be a bit harder. All right, so you would have 23 full payments, all right, and then your final repayment would be a little bit less. So see how I changed the future value to 0 and then wanted to find out how many installments I needed. So did I say months or years before? I can't remember. So we've got 23.9. So that's the installment periods. And because we're dealing with months, that is in months. If I did 24 months, of $350, I'm overpaying that loan. So you'd have 23 payments, full payments, and then your final payment would be slightly lower. Alrighty, let's move on. And there's heaps of exam questions like that, so I might pick out a few and do them in a separate video. Alright, David borrows. Alright, so he's borrowing this time, so it's going to be a loan, $50,000 for a new car at an interest rate of 4.6% compounding weekly. He repays the loan over 3 years with regular payments. All right, usually the payments are a weird number, and that's because of compounding interest. It's never straightforward. If it was simple interest, it would be quite simple because it's the same amount each time, but same amount of interest, I should say. But because compound interest changes all the time, the amount of interest in dollars changes all the time, that's why your repayments are usually, you're like, oh, that's such a weird amount. But yeah, it would be the same as if you were to actually do it in real life. It wouldn't be as straightforward. Okay, except for the final payment. So just putting that in because they're not always going to be exactly $343.27. How much does David owe after 1 year? Round your answer to the nearest cent. All right, so going back onto Financial Solver, let's clear what we had there. So just go to clear page. All right, so we're looking at 1 year and it's weekly. So 1 year times 52. I mean, I could have just written 52, but I put that in there just in case if it was like 10 years or whatever, you can see how you would calculate it. You don't have to do it in your main screen. Your interest rate is 4.6. The amount being borrowed is $50,000, and that's positive because it's in your pocket. The payments being made, remember, are negative because it's going back to the bank. All right, and future value is what we want. We'll come back to that. And then we're doing it weekly, so we're going to have here 52 and 52. They're always going to be the same. All right, so how much does he owe after 1 year? So $34,093.96. So just make sure you get that rounding correct. What is the final payment that David must make to fully repay the loan in 3 years? Round your answer to the nearest cent. So if I just make that like I did before, we want it to be 0, and I change this is what we want to calculate. Notice how it's 156 months. So what we've got here is if I did have 100, so if I did 156, see how we got all this, it is pretty close to 156, isn't it? But it's going to be slightly off. So if I did 156 and did future value, we're still owing $1.37. So that $1.37 is likely to be added instead of probably going into another month. It would be added to your final payment. If it went into 157 months, it wouldn't be repaid in 3 years. It would be repaid in 3 years and 1 month. So that $1.37 would be added to the $343.27. So I would just write that down and then put it into your calculator. So adding those two values together, they're only negative because that's not money that's yours, it's in the bank. All right, moving along. All right, Kazoo invests $50,000 into an annuity, paying 6.1% per annum, compounding annually. Kazoo receives $6,825.61 per year for 9 years and then a final payment, so the annuity lasts exactly 10 years. State whether the PV is positive or negative. So remember, with an annuity, it is a type of investment, so it is money going to the bank, but if you're unsure, remember it says here. So annuity is negative, but the payments you receive are positive because they're coming back to you. All right, let's go back on here. All right, so PV is negative. Find the value of the annuity after 5 years. Round your answer to the nearest cent. So Just using the financial solver again. Let's clear what we've got. All right, so it's doing it for 5 years and it's compounding annually. So we'll just do 5. Interest rate is 6.1. Let's move you up. So the investment amount was 50,000. Payments, because they're coming back to you, is going to be positive. So 6825.61. Future value, we'll just leave that for now. Annually, sorry, so it's 1 and 1. All right, and after 5 years, yeah. So there we go. So you've got $28,674 left. You do need to put 0.00, so make sure with financial, even if it's like a whole dollar like this, you would get you wouldn't have any extra cents. You do need to account for the cents, so do put 0.00. If you didn't do that, it would be marked wrong. So always with financial 2 decimal places. All right, what is the final payment made to Kazoo so that the value of the annuity is 0? All right, so if we do it for 10 up here, all right, and then change your future value, you can see how it's got 12 cents, or sorry, not 12 cents, 13 cents left. So you still get the 10 full payments, but the final payment is slightly more because you've got 13 cents left over. So your final payment would be still the $6,825.61 plus that extra 13 cents. So it's going to be slightly higher than the other repayments. All right, I think that's it. So yeah, just adding those two values together. All right, next one. Eliza invests $20,000 into an annuity paying 7.2% per annum, compounding monthly. The annuity regularly pays $1,732.37 per month for 11 months, followed by a final payment to exhaust the annuity. So exhaust just means it's finished. All right, so let's just highlight a few things. So $20,000, it is an annuity paying 7.2% per annum, and it's compounding monthly, and it pays that amount per month, and then for 11 months. And then got a final payment. Find the value of the annuity after 3 months. All right, so let's get on to the calc. Let's clear what we had before. All right, so we're only doing it for 3 months, sorry. The annual interest rate was 7.2. All right, principal value, so remember an annuity is money going towards the bank. But then you get regular payments, so that's money coming to you, so the next one is positive. So remember, you can use your notes if you forget. And it's compounding monthly, so you got 12 and 12 down the bottom. Come on. All right, so how much is it? There it is. So $15,133.81. Part B, what is the final payment? So it's 0 after 12 months, so we're just going to change that 3 to 12, and then we go back down to the future value. So just like before, we have our original payment, so the $1,732.37, and then we're going to have an extra 12 cents. So we're going to round that up to 12 cents. So add those two values together, and that'll give you your final payment. All right, last question. Ezra is going backpacking around Europe and has invested $15,000 into an annuity for this trip. Is that the last question? I thought I had some. Is this a perpetuity? No, I thought I had some perpetuity questions. All right, sorry, getting distracted. Ezra is going backpacking around Europe and has invested $15,000 into an annuity for this trip. The annuity pays 6.8% per annum, compounding weekly for 1 year. The annuity pays $298.57 per week, each week, except for the final payment. All right, find the value of the annuity after 26 weeks. I feel like these are getting very repetitive. That's right. And I also realized there's harder questions, so we might do a different video. All right, so 26, annual interest rate is 6.8. Principal value, so we're investing it or putting it into the bank or wherever. Payments we're receiving, so that's positive because we're getting that money. So 298.57. And then future value we'll calculate. It is compounding and making payments weekly, so 52.52. So there's your future value, so $7,627.37. What is the final payment after 1 year? So we change that to 52. And then change your future value. So you'll notice that this time it's negative, so we'll have to do $298.57 minus 6 cents. So it would be $298.51. So just slightly lower because this time it's come under as opposed to over. So just make sure that you take off that 6 cents. All right, guys.